What's up, everyone? Welcome back. Patrick here, moving on to the next example on the Unit 1 Advanced Functions test. This is another example dealing with piecewise functions. And so what we have to do is find the constants m and n. So this piecewise function is going to be continuous. Now, as usual, what I recommend, pause the video now, try this question yourself, try to find the m and n values, and then watch the video after, see how your process compares to mine. We've done a couple of examples like this in the lecture videos, which I hope you've watched before trying the test, and see how your process is, and see if there's maybe any gaps or any weaknesses in your process. It's best to find them now when you are doing a mock test like this versus when you're going to be doing your actual test in school. So if you do find any weakness in the process, you may have to go back to the lecture videos and go through them again to review how all of this works. So if we're trying to make this piecewise function continuous, notice that we got three pieces here. Now these first two pieces, so this linear function, negative 4x plus m, and this exponential function, 2 to the power of x plus n, which x value are they meeting at? They're meeting at this x value of negative 2. So in order for this to be continuous at that x value of negative 2, both of these have to have the same y value. So what we could say here is we could say at an x value of negative 2, we know that negative 4x plus m has to equal 2 to the power of x plus n. Like that, right? So that's where the first two pieces are going to meet at that x value of negative 2. Now, notice that this second piece again, 2 to the power of x plus n, and this third piece, 10, this y value of 10, they are meeting at this x value of 3. So we know at that x value of 3, the y values have to equal, right? So we know that at that x value of 3, basically that second piece has to equal that third piece, like that. And then from here, all we have to do is basically plug in our x values for both of these equations, and then we'll have two equations and two unknowns, m and n, right? So if I plug in negative 2 here, we'll have negative 4, negative 2, plus m, and then over here we'll have 2 to the power negative 2 plus n, like that. So this will be 8 plus m. Now 2 to the power negative 2, that's like 1 over 4, right? It's like 1 over 2 to the power positive 2, which is 1 over 4, plus n, like that. And then over here, if I plug in 3, 2 to the power of 3, that gives us 8 plus n is equal to 10. And actually notice here, we only have one variable, n. So we could solve for the n value right away in this equation. So this question is actually not too bad. A lot of times you'll have the m as well in this equation. So you'll have like an 8m plus n equals 10, for example. And then you'd have to go through a more intense algebraic process. Not too intense still, it's still grade 10 math, substitution or elimination. But a lot of times you're not just going to get a single variable like this. But in this particular question, we got lucky. We could solve for that n value of 2. And then notice we could plug in that n value of 2 right here. And then we could solve for that m value. So we got 8 plus m equals 1 over 4 plus 2. Now I'm going to get rid of this fraction 4. So I'm actually going to multiply everything by 4. So you got to make sure you multiply all of the terms. Now you don't have to do this. You can work with the fraction if you want. Whichever way you do it, just make sure you're going to get the same answer that I am in the end. I personally like to multiply everything by the lowest common denominator so I can get rid of these fractions. So 4 times 1 over 4 is just 1. And then we got 8, like that. So this would end up being what? 32 plus 4m equals 9. And so what? We would have 4m is equal to 9 minus 32 would give us what? Negative 23. And so m would be negative 23 over 4, like that. All right, so that ends up being the final answer to this question. The n value is 2, the m value is negative 23 over 4, and those constants would make that piecewise function continuous. And that's a wrap for the video. Hopefully you enjoyed that. If you want to see more videos like this, please go to my website, allthingsmathematics.com. Over there, all of the videos are organized by chapter, by section. If you feel like you need tutoring at any point, you could also hit me up. My contact details are on the website. Enjoy your day, and I'll see you in the next one. Peace out.